All right, this is a review of a chapter of Algebra 1 that talks about rational expressions and functions and all of that jazz. So we start off here by solving proportions, and our instructions tell us to remember to check for extraneous solutions. An extraneous solution is something that can happen through the process that we use to solve proportions, that sometimes we'll get an answer that shouldn't have really been an answer. And it's really easy to tell when this is, because what happens is if you plug it back in just to your denominator of your fraction, where if there's a letter down here like x plus 3 or something, if you plug it in where this x is and it gives you 0 on bottom, then it's not really a solution. So if I had a proportion set up like this, it doesn't matter what the rest of it is, because I wouldn't be able to magically pick the right numbers anyway. If I had this and I solved it and my answer was -3, well, if I plug in -3 right here, I get 0, and in math we're not allowed to divide by 0. So that would clue me into the fact that x equals -3 should not really be an answer. So that's what it means when it says to remember to check for extraneous solutions. So on each one of these, I'm going to cross multiply to solve. And every now and then there will be some that you can do maybe in your head. But at this point, since we're in Algebra 1, we usually as teachers try not to pick ones that are that easy. So maybe you could have come up with this strategically without cross multiplying. But if we cross multiply, 3 times 7 is 21, r times 9 is 9r. This is a linear equation that we can solve by dividing both sides by 9. 21 over 9, we want to simplify by reducing it on top and bottom by 3, because it has that in common. You don't have to change this to a mixed number unless your teacher wants you to, but I think most Algebra 1 teachers hopefully are fine with you not changing it to a mixed number and leaving it as 7/3. So to check if that's extraneous, we just think about, if I put it on the bottom where that r is, does that give me 0 on bottom? Well, no, it gives me 7/3. So this is not an extraneous solution, it's a real solution, or a correct solution. So number 2, we're going to cross multiply as well. We've got 10 times 4, which is 40. We've got 2 times b minus 8, and it's important to make sure to distribute that 2. You don't necessarily have to write down that step in between, as long as you times both of these by 2, so we get 2b minus 16. Then this is a linear equation, so we're going to add 16 to both sides, and then divide both sides by 2. So we get 28 for b. And then if we think about plugging this back in, we have 28 minus 8, which is 20, and that is not the same thing as 0, so we are good. That is a real solution, or a correct solution. Real means something different usually, so I mean it's a correct solution. So still going to cross multiply, and really the only difference in these problems is the type of equation that we'll have. There's a little bit different things going on with our equations that we end up with that we have to solve. But it's possible that at this point you could pause the video and try to work them out yourself to see if you got the hang of it. So again, this 2 we need to distribute when we multiply. So we have 4a equals 2a plus 18. So to solve an equation like this, we want to get the a's on one side, so that we have 2a equals 18, and then divide by 2. So a equals 9. And we can check that. If I put a 9 right here, it does not give me 0 on the bottom, it gives me 9. So it is not extraneous. And on 4, which is the final one of these problems, we're just going to take this and multiply, and so we'll distribute twice here. So distribute the 10. It's really easy to forget to actually distribute. Even if you draw the arrows up above, it can be really, really easy to forget to write down, like to actually multiply. we want to get the p's on one side and the numbers on the other. So I'm subtracting 7p over toward the left and I'm adding 100 over toward the right, or you could do that the other way around. 100 minus 63 is 37, so we'll divide both sides by 3. And 37 over 3 doesn't actually reduce, and we don't have to change it to a mixed number, so that's our answer. It's very common on these problems to get things that end up being fractions, just the way these problems work. 37 over 3 minus 9, I don't know what it is, but it's definitely not 0 because just 9 minus 9 is the only thing that gives us 0. 10 minus 10 gives us 0. 37 over 3 is in between 9 and 10, but it's not 9 or 10, so it's not an extraneous solution. Our next section of problems has to do with simplifying. So we have the bottom here, which we can factor. So as we're looking at simplifying on these fractions, either everything has to be divisible by the same thing. So n plus 7, n squared, negative 2n, and negative 63. Either we have to be able to divide all of them by something, or we have to be able to factor. So none of these don't have something in common. Yes, the 7 and 63 have something in common. Yes, the n and the n squared do. That is not how this works. That doesn't help us at all. They have to be either the exact same, or they have to have the same thing in common on top and bottom with every single term. But what we learned in our last chapter was how to factor the bottom of this into two parentheses, to split this up so the n squared turns into n and n, and the numbers we're going to put here in our parentheses come from what multiplies to get negative 63, that adds to get negative 2. And so it may be that that's easy to think of. It may be that that requires some effort here. I think our only options are 1 and 63, 3 and 21, 7 and 9. One of them needs to be negative to get a negative 63, which means we are going to pick 7 and 9 because 7 minus 9 is negative 2. So we put a plus 7 and a minus 9. Now, if I have an n plus 7 and an n plus 7, I can cancel those out because those are the same. And that leaves me with a 1 on top since I canceled out the only thing that was on top. My answer is 1 over n minus 9. On 6, okay, same type of problem, but slightly different. We don't have something in common with all of them, so we're forced to look for ways that we can factor. There's another kind of factoring other than what we did on number 5, where we look at our terms and see if they have something in common. So both of those numbers can be divided by 8, and that would leave us, if we divide them both by 8, with just 1n and plus 9. And so what we can do is we can rewrite 8n plus 72 as 8 times n plus 9. And that means these n plus 9s can cancel out, and our answer is just 8. So those are the kinds of things we are looking for on these problems, is we're looking either for something in common with all of them, or we're looking at some way that we can factor either the top or bottom or both so that we can see things that will cancel. So on 7, this is what I mean by if there's something they're all divisible by, we can just divide by it. So I can divide all of these by 8 and n. They all have an n. So I'm going to go through and divide them all by 8n. But this only works because all 3 of them divide, and I have to divide all of them. And this is the same kind of thing that we're doing when we simplify something like 3 over 6 and we divide the top and the bottom by 3 to simplify it. We just have an extra term here that we're having to account for. So this gives us 6n squared over 7n plus 2. And that's our answer, because now there isn't anything in common with all 3 of them. There's also not anything in common on bottom that we might try to take out. So we're done with that problem. Number 8 is similar to, what was that, 5 that we did? That the top is something we can split into 2 parentheses. The bottom, we can't do anything with r plus 6 because it doesn't have anything in common, doesn't split up at all. But on top, we can say what multiplies to get 12, that adds to get 8. which is 6 and 2. So we want to look at what's in common on top and bottom. They both have an r plus 6, and so that leaves us with r plus 2. New type of problem. We've got multiplication and division. So the thing to remember with division is that you flip the second fraction. And I have a couple of ways that you can remember it that neither of these are original to me. I've heard them from other people. One of them, and you would have maybe heard of these when you were just doing regular division of fractions without x's. One of them is that you skip, flip, multiply, which what it's doing is it's reminding you skip the first fraction, you flip the second one, and then you change it to where it's a multiplication problem instead of a division problem. And then the other way that I heard more recently is that you want to flip the right fraction, not the wrong fraction. Get it? Flip the right fraction, not the wrong one. Right as in it's on the right side. You get it. It's okay. All right, so we want to flip this second fraction so that the bottom is on top and the top is on bottom. We're not rearranging the top or the bottom like in and of themselves. We're just rewriting the order, basically, that the bottom comes first, the top comes second. Now, that didn't actually help us a whole lot. The x minus 11 and the 1 we can't do anything with, but we can factor the top and the bottom of the second fraction. So we can say what multiplies to get negative 55, that adds to get negative 6. So 1 and 55, 5 and 11, those subtract to get 6. So plus 5 and minus 11. I can tell which signs to use based on whether or not I want to put them together and get a negative 6 or a positive 6. 5 minus 11 is negative 6. Negative 5 plus 11 is positive 6. I want to multiply to get negative 70 and add to get 3. And it may be that you think of it right away and don't need to make a list. I wish I'd given more thought to it so that because 7 and 10 is not obvious exactly, but was way easier than trying to come up with 5 and 14. Do I have the right things here? Yes. And so if I look at the top and bottom of both my fractions, the x minus 11s will cancel, because when we're multiplying fractions together, we can cancel from one numerator to the other denominator, or inside the same fraction, we can cancel numerator and denominator. As long as one of them's on top and one of them's on bottom, we can cancel. So that's going to leave me with x plus 5 over x plus 10 times x minus 7. None of the rest of these can be simplified. You can't cancel the 5 and the 10, even though if it was just a 5 and a 10, they would cancel and make a half. Having x plus something changes that. It doesn't work. On 10, it's multiplication, so we don't have to flip anything. And actually, right now, I could go ahead and cross those out. And so really, this is like having x squared plus x minus 42 over x squared minus 5x minus 6. I will need to factor both of these. And it may be that nothing actually simplifies after I factor, but factoring is what we use to check to see if it simplifies. So what I mean is I could get 4 things here that are completely different from each other, and that would mean that was my answer. But I wouldn't know that unless I went ahead and did this factoring thing. So I want what multiplies to get negative 42 and adds to get 1, which is positive 7 and negative 6. I want what multiplies to get negative 6 and adds to get negative 5, which is negative 6 and positive 1. I just made that big speech about things maybe not canceling, but most of the time they will cancel. So if you mixed up the signs here on one of these, you would want to double check to make sure that you really thought it through, because the point of the problem is that those cross out. And so if you're not getting things that cross out, it could be that you're not supposed to be able to cross anything out, or it could be that you're not doing the problem correctly, because most of your problems should simplify, if not all of them. So our answer is x plus 7 over x plus 1. Sorry. More division and multiplication. So at this point, you might think about pausing the video and giving yourself some time to think about it on your own to see if you've got things figured out. Otherwise, we'll just continue along. So we want to flip the second fraction. And there's not anything we can do with n plus 1 or 1. But there is something we can do with the 5n squared plus 30n. They both have a 5n. The bottom doesn't also have a 5n in common. So when that happens, we do have to write down what we're saying is in common, 5n. And then we are going to write n plus 6, because 5n squared divided by 5n is n. 30n divided by 5n is 6. So it looks like n plus 6 and n plus 6 cancel out. And then the 5n and the n plus 1 just need to go next to each other, like so. And the final one for this section, we are multiplying. And so we are going to have to factor the top and bottom of the second fraction. We don't have to flip it though, just need to split it up. So 6n squared plus 42n, they both have a 6n you can divide by and be left with n plus 7. And then the n squared plus 9n plus 14 will factor. And we're looking for what multiplies to get 14 and adds to get 9, which is 7 and 2. So the n plus 7's cancel, the n plus 2's cancel, and we're left with 6n over n minus 3. Nothing else cancels because all three of them would have to cancel in order for us to be able to simplify it any further. So that's multiplication. Now we're going to move on to addition and subtraction. And as usual, addition and subtraction ruins everything, makes this way harder. At least that is what has happened as far as fractions go. Sorry. Okay, so if we look at the middle, it's telling us to add. When we add and subtract fractions, we need common denominators. And so these two problems, thankfully, already have common denominators. So we're not going to have to do anything to be able to just add right away. We want to add the numerators together. We want to do 5 plus x minus 3y. So those don't actually add together because they're not like terms. So they just all end up next to each other. We check to see if there's something that everything can be divided by, or some way that we could simplify this like we did in an earlier problem. There's not, so that's our answer. When we subtract, we have to be careful. So we still have a common denominator, and notice that your denominator doesn't change because it's common to all of our fractions unless we start simplifying something. But we want to pay attention because we're saying u minus u, which is 0, and 2v minus negative 4v. What's happening here is we're going to have to distribute this negative. So we're really subtracting u and adding 4v, and so the u's cancel and it leaves me with a 6v. Now since it left me with a 6v, I actually have something I can simplify now. If there's not a positive, or if it's not addition or subtraction on top or bottom and all we have is multiplication, we're allowed to take these v's and cancel, and we're allowed to take the 6's and cancel. It's only if it was 6 plus v, right, then we wouldn't be able to do it because then we'd have to look for another 6 plus v. But we're allowed to say this and this cancel, this and this cancel, and that leaves me with 1 over 2u cubed v. So that is our answer. On 15 and 16, we do not have common denominators. And so that's what our first step is. We want to come up with a denominator that we can get both of these to equal. And we would like for it to be the least common denominator because it'll make the problem easier if it's the least common denominator. So we want to think about 6, which is 2 times 3, and 2y squared, which is 2 times y. And we want to combine those with the fewest things possible. So they need a 2 because they both have a 2. They need a 3, and they need 2 y's, and so together that means our common denominator is 6y squared. Once we figure out what our common denominator is, we have to make our current denominators turn into that. So how do I take a 6 and turn it into 6y squared? I have to multiply by y squared. But if we do it to the bottom, we have to do it to the top, because that means that we're really just multiplying by 1. So y squared times 5 is 5y squared. Then on the second one, I need to change 2y squared into 6y squared by multiplying by 3. So 2 times 3 is 6. The other way of thinking of it is also like, if you write it out like this, like comparing what we had with what our end result was, like the 2 and the 3 needed a y squared because this is what it didn't have. The 2y needed this 3 because it had everything else. Now we're going to add our numerators together. 5y squared plus 6 doesn't actually add and combine in any way, so we just write it out. This doesn't simplify since they don't all have a y and they don't all have a number we can divide by. So that is our answer. There's also another way we could have done this, and I will point that out on 16. You also can look to see if you can simplify at the beginning. For instance, 2 over 2 cancels and makes this 1 over x. And we can actually do the same thing here. 6 over 2 cancels and gives us 3x over 1. And so maybe that makes it easier to tell what the common denominator is. If so, then go for it. You also, though, can just solve it the way it was and get a least common denominator that way. If we have this, our common denominator is x, because we can just times this fraction by x to get an x on bottom. So that gives us 1 over x minus 3x squared over x, which is just 1 minus 3x squared over x. Again, nothing cancels because they don't all three have something in common. These last two are a little trickier, but are also, they're just different actually, not necessarily trickier. There's no way to make n minus 2 be n minus 4 or vice versa if we're only allowed to use multiplication. We're not allowed to just add 6 or something to the first fraction to make it turn into, that wouldn't even work. We're not allowed to subtract 2, is what I mean. I can't just subtract 2 to turn this into a negative 4. It has to be multiplication. So that means that our common denominator is actually n minus 2 times n minus 4. It's the same thing as when you were doing fractions back in the day, and you may have noticed that like with 6 and 7, all you had to do was multiply this one by 7 and this one by 6. Like you could flip-flop your denominators and that would work. Same thing is happening here. I'm going to multiply this fraction by n minus 4. And I'm going to multiply this one by n minus 2. And get my new fractions by doing that. So I'm going to have to distribute. I'm going to actually rewrite a step in between here. I have 3n times n minus 4. I've got minus 5 times n minus 2. And that's important because we're going to distribute that negative as well as the 5. We're also going to distribute the 3n. This is 3n squared minus 12n minus 5n plus 10. So 3n squared minus 17n plus 10 is going to be over our denominator. You never, ever, ever need to multiply out this denominator, because if anything, we want to factor the top of this to see if there's something that will cancel. Now, there's many different ways you can choose to factor this. You can guess and check. You can use slide and divide. You can use the box method. Whichever way you do it, you should end up with 3n minus 2 times n minus 5. And so it does not actually simplify at all. So you may think, well, did I even need to do that? I would argue yes, because what if they did cancel out? Now you know for sure. But I suppose if you're just like lazy, then in this particular case, it wouldn't have hurt you not to factor it unless your teacher requires that as a part of the process. So on 18, we want to multiply both denominators by each other, or both fractions by the opposite denominator, because our common denominator is a combination of k minus 1 and k minus 3. So we're going to do 6 times k minus 3 plus 6 times k minus 1 over k minus 3 times k minus 1. So 6k minus 18 plus 6k minus 6. I'm just going to squiggle. That's obviously the denominator again. Here's 12k minus 24. And I'm going to squiggle again because actually this factors, and we want to check to see if factoring is helpful here. We can take out the 12 and get k minus 2. And so then we've got k minus 3 and k minus 1. I feel like that was so close to canceling. If only there was a k minus 2 on the bottom. All right, finally, we have some problems on solving equations with rational expressions. And it, again, reminds us to check for extraneous solutions. So in a similar fashion, there is a possibility that we could solve one of these and end up getting an answer that's not really a correct answer. Our goal is basically to get a common denominator for all of these fractions. And there's kind of two different ways of looking at how we're doing this. So if I can look at 3v and 3v squared and understand that the common denominator is 3v squared because that's what I can get them all to equal, then one way of thinking of it is to multiply each of these things by 3v. And I'm going to write it down, even though you probably could do this in your head. I'm going to multiply all of them by 3v squared. But what you should notice is that there should be things that cancel out along the way here. So for instance, 3v and 3v squared cancel out and leave me with v. And 1 times v over 1 is just v. And here this v cancels out with this v squared and leaves me with a 3v on top times 1. Here these cancel out completely, leaving me with just the v plus 6. And now I've got a pretty easy equation to solve. I get these v's together, and then I subtract this v over here and get 3v equals 6. So I divide both sides by 3. I missed that. Okay, and get 2. Now 2 is really the answer because when I plug in 2, it doesn't give me 0 on bottom. The other way to think about it that you might like better is if it still requires us knowing what the common denominator is, but instead to just go ahead and get that common denominator by timesing this by v, timesing this by 3v, timesing this one by nothing, and then rewriting it. And we actually get the same exact thing right here with just less writing. So it depends on which one you think is easier. It gets us this right here, but it gets us this actually with our denominators still there. And so we would have the idea added in there of dropping our denominators since they're all the same. That if they were all the same denominator, we wouldn't really need the denominator, which is something you probably talked about back in pre-algebra as well, that you can make everything. Well, you did the same kind of thing in pre-algebra, just without the letters on bottom. So we could try that method on the second one here. We would say, this is 2b squared, this is 2b squared. I can get this one to match by multiplying by 2b. That's going to make it also be 2b squared. And so because they'll all have the same denominator, I won't need the denominators anymore. I'll just write the numerators, and 1 times 2b is 2b. So I'm going to do b minus 5 equals 2b, and then subtract b over and get b. And again, I plug in -5 to the bottom here, and it doesn't give me 0 on bottom, so it's not an extraneous solution. And we're going to do something similar on the rest of these problems. So I can either And it's really up to you which way you prefer to do it. So if I think, okay, I can get all of these to be 6a, I can think about multiplying them all by 6a to cancel out. So the 6's would cancel and it would leave me with a. The 6a's would cancel. So the 6's would cancel here and leave me with a. The 6a would cancel completely here and leave me with 1. The 6a would cancel with the 2 and leave me with 3a here. And then now I've got an equation to solve. So subtract 3a and get negative 2a equals 1. Divide by negative 2. Get a equals negative 1/2. On 22, our common denominator is 6n. And so the first denominator, the 6n's cancel, and it leaves me with n squared plus 10n plus 24. Here, the 6's cancel, and so I will have to multiply by n. Here, the 6's cancel, and I will still have an n. So I'm going to have to do some work here. I'm going to have to distribute this, and I will at some point have to subtract the n. Well, maybe not, actually. Let's just do that first step. I don't want to spoil it for you. I'm going to multiply by negative n and get 6n, and then get everything on one side of the equation and solve. And so, which actually that's not right. The n squareds and the negative n squared, that cancels. So I don't need to get everything on one side. I can just solve this like a normal equation now. 10n and 6n together make 16n. And then I'm going to subtract the 16n and get 24 equals negative 15n, and then divide by negative 15, and that simplifies by 3. I feel like I went a little fast there on that last part, so feel free to go back and watch it again and just think about what's happening. I distributed, I added like terms, and then I solved for n by getting it all on one side. Or not all on one side, why do I keep saying that? By getting the n by itself. Last two here, and so hopefully you're getting the hang of it. Like here we have an n squared, a 5, and a 5n, so we want 5n squared. So that means this first fraction just needs a 5. This one just needs an n squared, but already has a 2, so that's 2n squared. This one needs an n, and so we'll have to do n times n plus 6. So we need to distribute on the right side. And because we have an n squared on each side, we're going to start by getting those together, and preferably in a positive sort of fashion. So we've got 5 plus n squared. All right, since it didn't get rid of the n squared, I need to go ahead and move the 6 as well. And I keep having this issue of writing n's as m's. You want to write it in order because it's a trinomial, and so our hope is that we can factor this into 2 parentheses by saying what multiplies to get 5 and adds to get negative 6, which is negative 5, negative 1. And then our answers are what makes each of these equal 0, which means that we switch them around and get n equals 5, n equals 1. And again, we check up here, do 1 or 5 make the denominators here 0? No. And in fact, on all of these, because I wanted to make the denominators relatively simple, 0 is the only answer that wouldn't have worked on, I think, all of these problems. So here I want 2m for my common denominator, so the first fraction needs an m. The other two already have our common denominator, so we're good there. We do have some m squared, so we need to get them together. They subtract each other off, and so m minus 6m is negative 5m. We're going to add 3m, or you could add 5m. We need to get them together, though, and we need to subtract a number to the other side. Make sure that if you get them on the same side, you wouldn't be done. Like Like there's a common mistake here because we've been getting everything on the same side of our equation to think that you still want it to be on the same side of the equation. No, if we get rid of the m squared, we want to get the number on one side and the m on the other side and then divide by whatever's in front of m. So m should equal 3. And that's this whole review. This is a lot of problems on rational expressions. Happy studying.
If you like this video, please hit the thumbs up and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture and I'll try to answer it. Thanks for watching.